everybody, and welcome to the podcast. Today we're going to be going over factor label, or actually reviewing the factor label method. We talked about it a little bit in class, but I'd like to go over in detail for anybody who had any questions on it. So, in our notes you'll find a slide that looks kind of like this, and I'll just go over the factor label method. Factor label is simply a unit of converting, a method of converting units. It's like saying I've got 3 meters and I want to find out what that is equivalent to in other units. It's like saying how many feet are in 10 miles or how many ounces are in 2 tons or whatever. So we're not changing the actual value of the of what we're measuring, we're simply changing the unit. So what we stated in factor label is that units like this is 3 meters right here, that's about 9 or 10 feet. 3 meters, the meter unit can behave just like variables. Like we say, I don't know, over here 3x over x. Well, we know that these x's cancel out and that expression is equal to simply 3. I'll do that right there. Well, meters can be done the same way. Any unit can be canceled out as well. So what we want to do in factor label is to take our original measurement and multiply it essentially by 1. Like if I take this and I multiply it by 1, it doesn't change anything, it simply makes it 3 meters. Well, that's true, okay? But if I multiply it by a fraction that is equivalent to 1 and also cancels out this meters and converts to something else, I can do that, and now I have a new unit. So I need to create a fraction right here where it does 2 things. Number 1, it's equal to 1. So the numerator and the denominator have to be equal. Right there. But also, I write this fraction with the interest of canceling out what was originally in the numerator over here. So I've got meters in the numerator, I want to write meters in the denominator, and put whatever I want to convert it to in the numerator, but then I must write the equivalent values. How many meters to how many centimeters? Okay, well, centi means 1/100th of something, so there's 100 of them in 1 meter. Okay, now I've made a fraction that is actually equal to 1, and I've enabled myself to take this meters, cancel out, and I've got a new unit now in the numerator. All that's left to do simply is just punch these numbers into my calculator and multiply across, and now I've got my conversion. So 3 meters times 100 equals 300 centimeters. Simple as that. Okay, now you probably could have done that in your head, but at least now you know how this method works. 300 centimeters. It's the same value, same amount of measurement, but just different units. Okay? So let's do some examples right here. These are already done. You see these in front of you. Actually, we may have written these out in class, but these are the completed values. I want to do them again just by hand so that you can see how we arrived at these values right here. So I want to convert 122 centimeters to meters. So I'm first of all going to just write out my initial value, 122 centimeters. And I want to create a fraction that is equal to 1 and also converts centimeters to whatever other unit. So my centimeters starts in the numerator here. I'm going to put it in the denominator so that it will ultimately cancel out. But now I've got to finish this fraction just so that the fraction is equal to 1. I want to convert to meters. I think I can convert centimeters to meters pretty easily. Centi means 1/100th, so there are 100 of them in a meter. And now I can cancel out my centimeters. Goes away, goes away. And this is actually very similar to what we just did a minute ago. But now I need to divide by 100. So 122 divided by 100, that equals 1.22 meters. Same value, just a different unit. Cancel units out by creating fractions and then crossing off that way. Let's do this one over here. 2.3. Actually, I'll do this one on Yeah, it is one on the bottom here. I got a feeling I'm going to need a little more space here. 2.3 kilograms. Alright? And I want to convert that to milligrams. Now, if you know your metric conversions, you may know that kilograms to milligrams is the order of 1 million, but we're going to do this in actually 2 steps here. So 2.3 kilograms. I'm going to write that out first, and now I'm going to multiply it by a fraction. Make that a little straighter there. Darn it. There we go. Multiply it by a fraction that's equal to 1, but also cancels out our kilograms. So kilograms begins in the numerator here. I'm going to write it in the denominator. I could convert it right to milligrams, but I may not know that off the top of my head, or it may be too much. So I'm going to write it out in 2 steps here. Kilograms to grams, I may be more familiar with. Okay, so what is that relationship? Well, kilo means 1,000. So in 1 kilogram, there is 1,000 grams. Okay, now my equation is equal to 1. I now can cross out my kilograms, and I've got a value now in grams, if I were to do my math right here. But I don't want grams, I want milligrams, so I'm going to do this again with one more step. Okay? So I want to convert grams now to milligrams. Grams is in the numerator here. I'm going to put it in the denominator. I want to convert that to milligrams. And do I know my relationship between grams and milligrams? Well, milli means 1/1000th of a gram, so there's got to be 1,000 of them in 1 gram. Okay, now I can cross out grams. Grams goes away, and I'm left now with the unit that I want, milligrams. All that's left is simply to punch in what I want in what I've got here into my calculator, and I'll have my new conversion in my new unit. So 2.3 times 1,000 times 1,000, that'll be 2.3 or 2,300,000 milligrams. Okay, just like that. You also may want to write this in scientific notation. You might say 2.3 times 10 to the 6th milligrams. That's perfectly fine as well. In fact, that's a little more concise. But that's how we do it. Alright? Let's do a little bit more complex ones here. Oh, this one I didn't... there we go. I forgot to delete that one. So we want to convert 24 meters per second now to meters per minute. So this is written kind of horizontally here. I always like writing my fractions very vertically up and down, so I know which is the top and which is the bottom, which is the numerator, which is the denominator. So 24 meters per second, that's going to be a velocity or a rate of speed. And I want it to be meters per minute. So this fraction here, this value I'm going to multiply by a fraction. Meters doesn't change, right? That stays the same, but seconds to minutes, that does change. So I want to get my seconds to convert to minutes. So it starts out here in the denominator. I'm going to put seconds in the numerator and write the unit that I want now in the denominator. Do I know the relationship between seconds to minutes? Sure I do. It's 60 seconds to 1 minute. So now seconds goes away. I'm going to black that out there. And I've got an answer now in minutes. So I take 24 times 60. And you'll see here that my final answer, meters per minute, is still here. It's a little broken up. There's meters, there's minutes. So my final answer is going to be in meters per minute. All right, 24 times 60, that's 1,440 meters in the numerator, minutes in the denominator. Meters per minute. Okay? So that was converting a unit in the denominator. Now we're going to do both. Over here, I've got 36 kilometers per hour. And we're going to convert that to meters per second. Now our numerator and our denominator have to change. So we need to convert both. We can do that. We can do it the exact same way we've been doing it. It just takes 1 or 2 more steps. 1 or 2 more steps of the same thing we've been doing. So let's get rid of kilometers first, just because it's in the top in the numerator. So I'm going to write out my little fraction brackets here. Let's get rid of kilometers in the numerator by writing it in the denominator. and I want to convert that to meters. So how many meters in a kilometer? There's 1,000 meters in a kilometer. Kilometers goes away. I'm left with meters in the numerator, which is what I want. Good. So now it's just a matter of converting hours to seconds. I'm actually going to do this in one step. You can convert hours to minutes and minutes to seconds, but we're going to do this enough that it should be stated right now what the relationship between hours and seconds is. Hours starts out in the denominator. Let's put it in the numerator so that it goes away. And can we convert that right to seconds? Yes, we can. There's 60 minutes in an hour and 60 seconds in a minute, so in 1 hour there is 60 times 60, or 3,600 seconds. This right here, you're going to want to just kind of put that into your bank of conversions that you know, because it'll save you a step in the future, and we're going to be doing it enough. So 3,600 seconds to an hour. Hours goes away. We're now left with meters per second, which is what we stated that we want. We want it in meters per second right here. It's simply a matter now of multiplying across. So that means we've got 36,000 meters in 3,600 seconds, or it really comes out to be 10 meters per second. Simple as that. Alright? And there we have it. Those are our more complicated ones. And finally, this is sort of a heads up for you. Most of our units that we're going to convert are going to be linear. Or that is, they're going to be in one dimension. However, there may be a circumstance where you'll come across where we need to convert maybe meters squared to centimeters squared. We've got exponents involved here. It is true that 1 meter equals 100 centimeters, okay? But it is not true that 1 meter squared equals 100 centimeters squared. That's not true. What we need to do is we need to not only square the units, but also we need to square the coefficient out front. So 1 meter squared, if we're going to write fractions where the top and the bottom, the numerator and the denominator are equal, we have to state that 1 meter squared is equal to 100 squared centimeters squared. Okay, that's how we would write an equivalent numerator and denominator fraction. We have to square the coefficient out front of whatever unit we're converting to. So let's ignore this right here. This is completely, that right there is wrong. I don't know how that got in there. But let's convert 0.25 meters cubed, okay, to meters cubed to centimeters cubed. Alright? So we're starting out with 0.25 cubic meters. It's an amount of space, it's volume. Alright, let's multiply that. So 1 meter cubed is going to be 100 cubed centimeters cubed. Our meters cubed goes away, and we're left now with an answer in centimeters cubed, and it's the right value, the right multiplier, the right coefficient out front. So 0.25 times 100 cubed, I believe that is 250,000 centimeters cubed. Okay, just a heads up, you're not going to come across this very often, but when you do, you need to make sure you square the coefficient out front of whatever conversion you're making, as well as the actual unit itself. Okay, just a little heads up on that part of factor label. So that's it. That's it with factor label. If you have any other questions, please let me know. You're going to be doing this a lot this year, so make sure you get this down cold. Make sure you can write this all out, because you're going to want to see all your calculations written out. Hope that helps. If you have any questions, come see me in class. Thanks for watching, and I'll see you next time.